Heights and distances. This is a problem picked up from Bombay Scottish Prelim paper dated 5th of Jan 2023. Let's look at the problem. The problem says the angle of elevation of a plane from a point P on the ground is 60 degrees. The angle of elevation is 60 degrees. So we know that this angle we're talking about is 60 degrees. So the plane is at point A in the beginning. So after 12 seconds, this is the journey that the plane takes. The angle of elevation changes to 30 degrees. From the same point, which is point P, the point of observation, the angle of elevation is changed to a 30 degrees. So this angle is 30 degrees with us. If the plane is flying horizontally at a speed of 600 root 3 km per hour, find the height at which it is flying. So we have got two information here, the speed with us and the time. So what we would be required to do is we would be required to figure out one distance, then apply the tan function with tan 30, tan 60, try to get some relationship between the PD and PC so that CD could be used. So here in this case, we are looking at measuring the distance CD. So here this is the length of time, which is 12 seconds. This is the journey that is completed at this speed. So we're looking at finding the distance. Therefore, as per the diagram, distance CD is speed times the time. So here we know that we have got kilometers per hour that can be changed to meter per second. So 600 root 3 kilometer per hour we change into meter per second. So we multiply with 5 over 18 because your distance, which is in kilometers, can be changed to meters by multiplying with 1000. Time, which is in hours, it can be changed to seconds by multiplying with 3688. So the easier way is 5 over 15. So we had speed, which we converted into meter per second, and we'll multiply with the time, which is 12 seconds. So here we look for cancellations. Our cancellation is here 6 times 2, 6 times 3, 3 times 1, 3 times 2. So here we have 200. So this would become, the distance would be 2 times 2 makes 4, 4 times 5 makes 20. So we have 20. There are two more zeros, root 3. This is meters with us. Now since we know the distance, we'll start using trigonometric function. Our function here we will use is in triangle APC. So here we are measuring in triangle APC, use tan of 60 degrees, which is, we have identified the perpendicular height at which the plane is flying is h meters. So we want to write AC over PC. Therefore tan 60, which is root 3, is going to be h over PC. Therefore our PC would become h over root 3. So we prefer rationalizing it. So times root 3 times root 3, that would become h root 3 over 3, that is our height, h. That is PC in terms of meters. Now we are talking in terms of meters. So now we want to move to the larger triangle, that is triangle PBD. In triangle PBD, we have tan of 30 degrees, which is opposite, which means BD, over adjacent, which is PD. Since tan 30 is 1 over root 3, so 1 over root 3 is h, again BD is the same height, h over PD. So therefore our PD would look like, our PD would be h root 3. We were interested in the distance CD. Therefore CD, which can be written as PD minus PC, is PD is h root 3 minus h root 3 over 3. So here easy case for us is LCM. So we go ahead with the LCM. This is over 1. So we multiply by 3, multiply by 3. So this is treated as 3 times h root 3. This is 1 times h root 3. 3 minus 1 makes 2. So we have 2 times h root 3 the whole over 3, that is distance CD in terms of meters. This is CD in terms of meters. So now we already had the distance CD because we had speed and we have time here. Speed into time gives you distance, so we already have this distance. We'll equate it here. So let's equate it here. Therefore 2000 root 3 is 2 times h root 3 over 3. So we realize that we can cut this root 3 and root 3 is lost here. 2 times 1, 2 times 1000 is here. So here we will have, therefore 3 times 1000 would become the perpendicular height, which is h. This is in terms of meters. Therefore the height at which the plane is flying, therefore the height at which the plane is flying is 3000 meters. That's the final answer. Thank you so much. We'll meet again.